Assalamualaikum warahmatullahi wabarakatuh, and good day to my dear panels, Dr. Aida Fazliana and Miss Anis Niza. My name is Faisal and I'm from section 3, and this is my final year project presentation 1. And this is my motivation part. I would like to express my gratitude to UTEM and Dr. Abdul Rahim for the encouragement and guidance critics. So yeah, harmonic source identification system. In a deregulating power scenario, harmonic source detection assumes significance in an interconnected power system, as we all know. The presence of harmonic in an electrical system means that current and voltage are distorted and deviated from sinusoidal waveforms. Harmonic currents are caused by nonlinear loads connected to the distribution system, which is from the result of nonlinear loads that convert AC line voltage to DC. That is what causes harmonics, yeah. Harmonics flow into the electrical system because of nonlinear electronic switching devices such as variable frequency drives, computer power supplies, and energy efficient lighting. One of the major effects of power system harmonics is to increase the current in the system. This is particularly the case for the third harmonic, which causes a sharp increase in the zero sequence current and therefore increases the current in the neutral conductor. And this is the software that will be used, MATLAB 2016 and Visual Basic 2006. As for now, my supervisor asked me to try using MATLAB before trying the Visual Basic. The rapidly growing use of electrical equipment in our technologies is the biggest contributor to power quality problems. The electrical power quality of power system has become an important issue and heightened of awareness of power quality among the electricity users. The ability to maintain voltage and current signals with constant amplitude and constant fundamental frequency presents the quality of electrical power supplied to the customers. The small interruption of power quality events can cause equipment failure and economical loss. The power quality events are voltage swell, voltage sag, undervoltage, overvoltage, interruption, and harmonic, interharmonics, transient, and notching. Monitoring and analysis of power line waveforms are assessment of power quality events. It's essential to measure voltage, current, frequency, harmonic distortion, and waveform to monitor the power quality, right? The use of power quality monitoring is to locate the source of the events that occurs. The parameters of the power quality are characterized by voltage signal in RMS value, voltage and current, frequency, hertz. The classification analysis is developed using the software system in MATLAB 2016. On the other side, the monitoring system proved that the quality of the offered power is within the pre-specified standards, and analysis that record the data or information for solving problems. Existing power quality monitoring needs improvement on their capability, efficiency, reliability, and accuracy. This project presents a design and development of the real-time power quality monitoring system. The system can monitor, record, and analyze the data from power line. All the parameters that are being measured are voltage RMS, current RMS, and frequency. The data will be recorded and stored efficiently. The performance of the power line system can be monitored. And these are my objectives: to develop user-friendly real-time power quality monitoring system that can measure and display power line parameters such as voltage, current, frequency, and total harmonic distortion. The second one is to classify power quality signals such as normal and interrupted signals. And for my project scopes are: system utilizes the Microsoft Visual Basic 2006 software and MATLAB 2016 software. This project can measure voltage RMS, current RMS, frequency, and total harmonic distortion. The voltage and current signals are measured between 0 to 350 VRMS and 0 to 0.5 ampere for single-phase power line. And this is my hardware vision for harmonic source detection using FFT. And this is the block diagram for it. So the figure shows a flow chart of hardware development before transfer to the hardware. In order to capture harmonic signals, DSO, digital storage oscilloscope, loads such as induction, motor, bulb bank, computer, capacitor, and etc. will be required. as a load. Voltage signals or current signals can be captured on digital storage oscilloscope, and from this signal, the data to harmonic analysis can be captured. And the next slide is for the literature review section. There are several common power quality events in power line systems. It is normally divided into 5 categories. They are transient, waveform distortions, short duration voltage variation, long duration voltage variations, and interruptions. As for transients, a transience in power quality is used to denote an event that is undesirable but momentary in nature. The first thing that comes to mind to most power engineers is the nation of a damped oscillatory transient due to RLC network when they hear the word transient. In a broader aspect, a transient simply brings the meaning part of the change in a variable that disappear during transitions from one steady state operating condition to another. Generally, transient can be classified into 2 categories, which are impulsive transient and oscillatory transient. Impulsive transient means a sudden and short duration disturbance by a very rapid change in the steady state condition of voltage, current, or both, that is unidirectional in polarity, either positive or negative. The most common cause of impulsive transients is lightning. Peak currents from lightning strikes can exceed 200 kA with 10/350 microsecond duration. The frequency range is more than 5 kHz, considered in the high frequency category. The duration of impulse transient is from 30 to 200 microseconds and generally occurs along utility lines. The occurrence of an impulsive transient can lead to transformer failures, arrestor failures, and damages to customer equipment. An oscillatory transient is a temporary rapid fluctuation in the steady state condition of voltage, current, or both that includes positive and negative polarity values. It is described by predominant frequency, duration, and magnitude. The subclasses are low, medium, and high frequency. And this is a waveform distortion slide. Waveform distortion is defined as a steady state deviation from an ideal sine wave of power frequency, principally characterized by the spectral content of the deviation. There are 3 types of waveform distortion, which are harmonics, notching, and noise. And harmonics occurs when nonlinear loads such as electronic equipment produce non-sinusoidal current waveforms when energized with a sinusoidal voltage. The next is notching. Notching is a periodic voltage disturbance caused by the normal operation of power electronics devices such as thyristors when current is commutated from one phase to another. Finally, noise. Any unwanted electrical signals with broadband spectral content lower than 200 kHz superimposed upon the power system voltage or current in phase conductors or found on neutral conductors or signal lines is defined as noise. The typical reason for noise problem to occur in a power system is because of improper grounding that fails to conduct noise away from the power system. The impacts of noise are disturbing electronic devices such as microcomputer and programmable controllers. The problem can mitigate by using filters, isolation transformers, and line conditioners. Moving to methodology slide, this is the project development flowchart. The project methodology of this project is shown in figure. This project will be divided into hardware, software, simulation, and analysis that involves troubleshooting of this project. This project will start with literature review that gives idea and better understanding about the project. The process of literature review is search for journals, articles, internet and book, and analyzing the relation to the system of this project. The project is then proceeds with designing the program of monitoring system by using MATLAB 2016. The designing program process is the part of this project that will be producing the desired output and measures the value of parameters of this project. The software must be suitable, the implementation that will be communicated with the hardware. On the same time, the hardware development is the start by designing the actual system for this project. The block diagram is the initial step to produce the desired result. The hardware design will be created and will be modified regarding the desired system. From the block diagram of the system, the components that include are alternating current supply, digital storage oscilloscope, and computer. The following task is to ensure that the combination between hardware and software will fulfill all the specification and achieve the objective. In addition, the data or result must be relevant with the system. After everything is complete, testing will be carried out to ensure that the system works perfectly. In conclusion, the analysis and troubleshooting for this project will carry out through the expected result. This is the hardware flowchart and the software development flowchart. This is the Gantt chart of the project progress for final year project 1. And let's move on to the result and discussion part. The first result slide is the simulating of MATLAB is present as shown. Secondly, the frequency spectrum of RMS impedance ohm over frequency hertz is displayed. The simulating can detect and classify all the quality events such as voltage input, voltage output, and current measurement and harmonic distortion. At the same time, waveform of all parameters from power line system is shown. In order to measure voltage input, voltage output, and current as an inverter circuit, the waveform shows that the voltage input is still constant, while the output of the voltage and current is in alternating current. The signal graph analysis of fast Fourier transform on output voltage waveform is displayed on computer, where the FFT analysis shows the distortion occurs, where it shows the values of fundamental frequency in Hertz value, total harmonic distortion, percentage, V peak to peak, and VRMS, and the current output, current peak to peak, and current RMS. As for the last two figures shows the input voltage and there is no distortion occurs. Finally, the fast Fourier transform analysis should be capable of continuous sampling and making a real-time analysis of collected data, recorded data, stored data, and the precision meet the requirements. The real-time power quality monitoring system should be capable to analyze the collected data stored in the database using the MATLAB software. And the final slide is for the conclusion. For the system's results and simulations result using MATLAB, and this project is successful and achieved its objective to measure voltage RMS, current RMS, and frequency in Hertz and total harmonic distortion. Besides that, the system can display the waveforms of voltage and current signal on computer. The results are available in real time through fast Fourier transform analysis. The system will be developed using MATLAB and Visual Basic on computer. Therefore, measurement of parameters from power line can be gathered and stored into computer. The monitoring system has the advantage of flexibility and allows the collection of data for a long time period. This system will exhibit excellent accuracy in calculation, and this project can be implemented in industrial environment with the right approach. And as for the future works, this project will keep on going until final year project 2. Hence, the future works for this project is to develop the hardware and using the Visual Basic software in order to generate GUI, graphical user interface. Then all the data will be analyzed to obtain the real-time monitoring system in the specific power line. Thank you very much for your time.